Alright, today we are graphing piecewise functions, and a piecewise function is really just a single function like h of x that's made up of by two different equations, or two or more actually. So when we look at this over here, just think of this first one at the top as y equals 1 minus 2x. And if we were just to graph that, what that would look like. So that's pretty easy to graph. We're just going to go to 1 here was the y-intercept, and then the slope is -2. So we go down 2 and over 1, down 2 and over 1, and we can go up this way also. Now the difference between graphing this and piecewise functions is what this is saying is these brackets here is this equation of a line is only good when x is less than -1. So if I were to think of graphing x equals -1, that would be right here. And if I were to draw kind of an imaginary line, maybe just to help us for now. And what we're saying is this line that we want is only good when it's less than -1. Less than is going to be in this direction. Okay, so all those numbers. So that's the only place that we have a line is right there. And that would go forever in that direction. Also, it's when x is less than but not equals to. So also we're going to have an open circle right here. And let me fill that in with white to make that clear. So there's one equation, and then what we're going to do is we're going to graph this second equation right here. So think of this one as y equals 2x minus 2. So we're going to go graph that one. Before that, let me erase the other ones here. So if we go to graph 2x minus 2, so we're going to start at -2, and the slope is going to be up 2 and over 1. And down 2 and over 1. Now if I were to graph a line without a restriction, it would just go all the way through all those points. But again, we only want this line, so let me actually just graph that real quickly. We only want that blue line when it is, as it says right here, greater than. So greater than, going this way, -1. So we don't want it when it's less than -1. So let me erase this part right here. And there's the graph of our piecewise function. It's equals to, so we're going to put a closed circle right there. And there's our piecewise function, which is made up of two different pieces, two different equations of lines. So that's one thing we can do with piecewise functions is graph them. The second one is we can evaluate and find different points on that piecewise function. So on this one we have h of -3. And so what is that saying? So here's what we're going to do on these. -3, we're going to look at that, and that's an x value, and we're going to see which x value that relates to. So up here we have x is greater than and equal to -1, and x is less than -1. Well, -3 is less than -1 on this top one. So we're going to plug that into that top equation. We're going to plug it into 1 minus 2 times -3. So that's 1 plus 6, which is 7. Let's try another one. What about -1? When x is equal to -1. Well, equals to, that's the bottom one. So x is greater than or equal to -1. We're going to plug that into the bottom equation. And that's going to be -4. So again, what we do is we first look at that x value that we're plugging in and look at the range that it is, and then plug it into the appropriate expression. So the last one here, let's do h of 2. So x equals 2. Well, 2 is greater than -1, so we're going to plug it into that relating one. So that's going to be 2 times 2 minus 2. So that's 4 minus 2, which is 2. Okay, so we can graph it, we could plot points, and this last part, we just want to make sure our answers kind of make sense. So at x equals -3, so if we go over 3, we should be up about 7, and that would kind of make sense. How about x equals -1? At -1, we should be down at -4, so 1, 2, 3, 4, and that works out. And the last one, we go over 2, so x equals 2, and we go up 2, and there's that point there. So these all work out and are related. The points are related to the graph.